Hi everyone, my name is Juan Pablo. Welcome back to a new YouTube video. In this time and in this video we will talk about a very important topic which basically many service providers have been facing in the last years and of course in the nowadays as well, some of them. And the topic that we will discuss today basically is how we can migrate from MPLS LDP into Segment Routing MPLS. Okay? As many of you know, MPLS was the must-go protocol for the service provider many years ago because it introduced a new paradigm of labels across the network infrastructure. Okay, if I had, for example, my network like this one is in the diagram, and I have, for example, here my customer router 4, right? I put this customer in a BRF, let's say BRF VPN, and the same the router 5, imagining that this is a customer, I put this in a BRF VPN, and of course I can provide here a layer 3 VPN service, and of course this goes over the core network infrastructure. So many years ago, this core network infrastructure basically was mainly configured by MPLS LDP, and this is where this paradigm of labels for passing traffic across different customers or different sites, for example, or companies like router 4 and router 5, it crosses over the network infrastructure, and of course LDP provide the labeled path for passing that traffic, right? So it was a must-go protocol for this type of service, for example, layer 3 VPN, and of course there are other services where MPLS LDP as well is very common, and it was very common to be used for EVPN, for example, layer 3 VPN, even for MVPN as well, right? So it was the must-go protocol for the labeling traffic in the core, okay? And of course, MPLS LDP has their own or its own label range, which is going from 24,000 plus, right? So if you enable MPLS LDP, the labeling assignment will start from 24,000 plus in iOS XR devices, for example, right? So, and as we mentioned in another videos, there were many requirements from customers, from providers, from the business perspective, and this forced to introduce a new protocol into the network, or create a new protocol, which is segment routing. Okay, and this is basically the evolution of MPLS LDP, and due to the many functionalities that segment routing provides, many providers were attracted to migrate to it. Okay, so how we can actually migrate if we have our network like this, for example, XR9K 1, 2, 3, which is we configure basically MPLS LDP, how we can migrate that network into segment routing if we already have the control plane and the forwarding plane of the label for this network. Well, there is one thing that is very, very important to know, is that when we enable MPLS LDP into the links of the core network, of course there are labels assignment and label distribution across the infrastructure. And this is what we call the control plane, okay? Control plane, where when we enable the interface, then every router assigns a label for every specific prefix, and it passes to the neighbor, and they exchange the labels, and that's how the control plane is built in MPLS LDP, right? Now, based on that label forwarding, for example, XR1 get to know that if XR1 wants to reach XR3, then XR1, for example, needs to use the label 24,003, okay? Because XR3 assigned the label 24,003, for example, it passed the label towards XR9K2 and say, hey, if you want to reach my loopback, this is my label, and XR2 sent that label into XR1. So that's why XR9K knows that he needs to send the label 24,003 if he wants to reach the loopback of ASR9K3. And when there is traffic from customer, router 4, for example, XR9K1 needs to, of course, send the traffic to 9K3 because if router 4 wants to reach router 5, then XR9K1 knows the prefix from router 5 as a layer 3 VPN service, and the next hop is XR3. So it needs to put a label, it needs to push a label, right? So that part of pushing a label and putting the packet into the wire and sending to XR2 is what we call data plane, okay? Or the forwarding plane. So MPLS LDP has these two concepts of control plane, distributing label, and data plane as well, which basically is pushing the label into the forwarding, the line card, and sending traffic over. That's to understand the both tables in MPLS LDP. If we want to migrate to segment routing MPLS, basically what we need to do is that instead of using the labels that we distribute in the control plane for MPLS LDP, we need to start using the labels for segment routing, right? Segment routing has a specific labels that it uses, a specific range of labels compared to MPLS LDP. The label range for segment routing is from 16,000 to 23,999 in iOS XR. MPLS LDP use labels 24,000 plus. So if we have already the network built, 24,000 plus will be the labels that will be assigned for LDP. If we want again to introduce segment routing, we need to first define the control plane. First, we need to enable the control plane of segment routing. Not yet the data plane. First, the control plane. Okay? So the first phase for migrating from LDP to segment routing is to define the control plane labels for segment routing. Okay? So we need to configure segment routing in the network, enable in every single device, define the prefix seed for the loop packs of the PE devices, manually define those prefix seed, enable segment routing MPLS, enable the control plane of segment routing. After we enable the control plane of segment routing, the second step is basically to replace the data plane from labels of MPLS LDP to labels of segment routing. So we need to tell every device, hey, use labels from segment routing from this range that you already have because we enable the control plane, and stop using the labels from LDP for every packet that you forward for every customer. Okay? And the second part, of course, might have a small disruptions over the MySNS windows, but not that much. Okay? It's not that bigger. Maybe slightly services that are high risky with latency, for example, or with a small distortion like 5 milliseconds or 10 milliseconds in the network. Those services might be affected a little bit, but it's not much longer than that, the disruption. Okay, it depends obviously as well if the network is big or small, but if the network is, for example, 40 devices, then is something pretty easy to do. Okay, so with this explanation, I just wanted to tell you migration from MPLS LDP to segment routing involves two steps. The first one, you need to enable the control plane to tell all the devices these are the labels of segment routing. So you need to first enable that and propagate across all the network infrastructure. And the second step, so first is control plane, and the second step is to tell every device use these labels in your forwarding of the traffic and stop using LDP labels. Okay, so basically the data plane. Okay, so these are the two single steps. For the first steps, you don't need to, there is no disruption in the network. You can implement that without any traffic impact. The second step, you need to, of course, be careful for this type of intermittence traffic in the network, depending of the size as well. You need to measure properly, but it's normally the second one that has to be taken care more. Okay, so this is in high level what we need to do in the network for migrating from MPLS LDP to segment routing. We need to do into steps again. Control plane first, make everyone aware that those are the segment routing labels, and later the forwarding plane, and basically tell every single device that use the segment routing labels and stop using the MPLS LDP labels. Okay, so what we'll do in this lab demo is basically the step number 1. Now in this lab we have MPLS LDP enabled across the 3 devices that you can see there, XR1, 2, 3. We have MPLS LDP. We will start to first enable segment routing in the control plane. Okay, so let's do it quickly. I will just stop the brush here. Let's start to do it quickly. So what we need to do to enable segment routing is I will go to PE1 and I will go to address family IPv4 unicast. Segment routing MPLS in iOS XR is the command that you enable the control plane of segment routing to start propagating the labels. Okay, there is, of course, you need to enable as well, very, very important, the global block. I told you that segment routing has a separate global, separate labels than MPLS LDP. The range is from 16,000 to 23,999. It's always best practice to enable segment routing global block globally. Okay, is by default in this range, but it's always very good to enable by manually as well. These are the 2 commands that you need to basically do for enabling segment routing. Of course, we need to define the prefix seed into the loopback. So we need to go to under the loopback of P1, for example, prefix seed, I will define the absolute value of 16,001. Okay. Again, if you don't know anything about segment routing, please take a look on my videos. I spend quite of time explaining segment routing. But in segment routing, in every loopback interface, you need to always enable a label manually. You need to define the label manually, because as we know, for MPLS layer 3 VPN, EVPN, or any type of service over a labeled core infrastructure, the loopback seed is always important, that it must be /32 and must have a label. Okay, so basically these are the two steps that we need to do. I just take a look in the configuration. Super commit. This will not disturb any type of traffic in the network. Okay, so I just do commit and I can proceed to the second device here. Okay, so here I can just go to ISIS as well and enable segment routing MPLS, and as well in the global configuration I just enable segment routing. Provider, in this case I am in provider router. This is XR9K2. I don't need to enable a prefix seed under the loopback, so I can just do commit here. Again, simply segment routing MPLS is the command for enabling the control plane of segment routing, not the data plane. We are now in phase 1, so we just need to do that. Okay, so if I go to again P3, I do exactly the same. MPLS, address family P4, here segment routing MPLS, interface loopback 0 for the prefix seed. Oh, address family P4, prefix seed absolute 16,003, and of course the segment routing global block, which is 16,023,9999. The same configuration as I did in P1. I enable segment routing in the control plane. Don't forget that this is the command to enable in the control plane. And of course, my absolute value for the loopback. In this case, I put 160,000. I will just change to 16,003. Okay, and commit. Now I have all the labels of segment routing enabled, and every device propagate those labels into the ISIS. Okay, so first, very important, I am just configuring the first step, control plane. If I do show seft, for example, in P1 to the loopback 3, loopback 0 of XR93, for example, show seft 3333, I will still see the label of MPLS LDP, 24,005. Okay, again, 24,000 is the range for LDP. I don't see yet the label of segment routing in my forwarding plane. In this case, also in my lab, and just to show you real quick, I have these VPNs that I told you, right? XR9K1 has a loopback 100 with the prefix 20110, and the other XR9K3 has a loopback 100 as well with the prefix 10110. And I am emulating a layer 3 VPN between these two. So I have BGP, multi-protocol BGP, and everything. And here I have MPLS LDP enable. So if I go, for example, to taking that concept, if I go to XR9K1 here and I do show Ceph to reach this prefix from XR9K3 under the BRF, it has to be MPLS label yet, right? So in this case, I have the loopback 100 in PE1, as I mentioned. So I will do show Ceph BRF BPN to the loopback of XR9K3 100, 10111, for example. As you could see here, we have a still 24,002, which is the label for reaching out 24,001. This is P1. Maybe let me just take a look here, the VPN. Yeah, show Ceph, for example, BRF VPN 10110. Yeah, well, now here I have traffic engineering. I'm so sorry. From the last video, I just forgot to remove traffic engineering. I will just remove. So then we will have a clear label stack. Okay, so now if I do show Ceph with the BRF VPN to the prefix 10110 on XR9K3, I have the label stack 24,002, which is the VPN label, and 24,005, which is the label to reach out the loopback 0 of XR9K3, 3333. Okay, so this is the 24,005 is the label to reach out the loopback 0 of XR9K3, and this is what we see when I type show Ceph BRF VPN on XR9K1. To the prefix 10, I see the VPN label and the label to reach out loopback 0 of XR9K3. Okay, so as we can see here is a still MPLS LDP label. Okay, now what I need to do to proceed with the second step or the second phase is to basically tell the device that don't use this label of MPLS, use the label of segment routing. Okay, that's the second phase. But before going to second phase, let me just verify that a few commands on segment routing. For example, show segment routing label table. I am now in P1. I type show segment routing label table, and I see that here basically I can see what are the labels for my loopback 0 of all the P devices in the network, basically the prefix it. So here I can see that I have the 16,001 for the 1111 and 1003 for the 3333. If I do show ISIS database, for example, and I put P3 as well, P3 of course is advertising his loopback into the ISIS, and in the loopback here I can see that I am receiving, maybe loop verbose detail, I am receiving over here the prefix index 3. Okay, so this is prefix index 3. If you look into my other videos about segment routing, is basically what we configure under ISIS. Okay, as an absolute value. So absolute we put 16,003, but the index is always carry on in the ISIS advertised, so it's 3, meaning is the last 3 of this value here. Okay, so basically here with these commands I can make sure that I am seeing the label from P3. We can make sure that we see the labels of the loopbacks as well of P1 and P3. So we can see that the labels for segment routing are being propagated. Just that when we type show Ceph 3333, still the labels in the forwarding plane between P1 and P3 is MPLS LDP. If I type show MPLS forwarding, you can see we see the label of segment routing, but we are not using that label of segment routing when I type show MPLS forwarding. Okay, we are using the label from LDP 24,005. Okay, as is seen in the show Ceph. Now, what we need to do is to go to the step number 2, which is basically changing the forwarding plane. We need to enable a specific command in ISIS and in segment routing, which is basically, I will enter into address only or Unicast, segment routing MPLS SR preferred. This command is the one that you need to enable in the maintenance windows or whenever you want to change the forwarding plane. Okay, if you enable this command, when for example in my topology, when router 4, that is a customer of XR9K1, wants to send traffic to router 5, and of course, again, this is a layer 3 VPN, then XR9K1, of course, needs to put the packet, the IP packet of the router 4, the VPN label that goes to the BGP, and it needs to put the label to reach out XR9K3 loopback 0. So now it's putting the label 24,005. Oh, sorry. Now it's putting the label 24,005 here. And when I apply this command, SR-prefer, it will not put 24,005, it will put 16,003. Okay? Because I am telling the device with this command, don't use the LDP label, use the segment routing label. Okay, that is 60,003 for reaching out the loopback 0 of XR9K3. Okay, so let's do that. I will just enable this command. And I will enable this command, of course, in all the devices in the network. Address family P4 unicast. It has to be this command in all the devices in the network because every device must use the label of segment routing and not the label of MPLS LDP. Okay, so I will enable in all the devices in the network. And when I type again now show ceph, you will see that the label changed. Now the label is 16,003. And if I type show ceph VPN, again to the prefix behind of router XR3, you see that the VPN label doesn't change, but the label of the core infrastructure to reach out router 3, it changed to segment routing. Okay? And if I type show MPLS forwarding, you see that it will prefer this line here. Before it was preferring this line here, and you could actually see some bit switches over here, more counters increase here because it was preferring here. If I do ping to the VPN label of the other router, for example 100, it works, and I type show MPLS forwarding again, it should start putting the counters for the segment routing entry in the MPLS forwarding. Okay, so this basically confirms us that is using the segment routing label. Okay, summary. Don't forget that MPLS to LDP, MPLS LDP migration to segment routing involves two steps. First, enabling the control plane, which basically is a segment routing MPLS label. Define your prefix seed in the loopbacks. You can do that without any problems in the network. Second, you need to enable the devices to use in the data plane the labels of segment routing. I hope you have enjoyed, and see you in the next video.